Very good morning, students.
Good
Can you hear
morning,
me?
sir.
Um, so today we are going to see the topic eigenvalues and the eigenvectors of the matrix from linear algebra. We know the definition of the matrix. Matrix is a arrangement of elements or numbers in rows and columns. Matrix is nothing but arrangement of numbers or elements in rows and columns. So there are two types of matrices. That is m by n, m rows and n columns. That is rectangular matrix and square matrix. So we are interested only in studying that square matrix. That is number of rows equal to number of columns. M equal to n. M not equal to n is rectangular matrix. In that square matrix, we classify into two types of square matrix. One is symmetric matrix and another one is non-symmetric matrix. What is symmetric matrix? That is if A equal to A transpose square matrix, A is said to be symmetric matrix if A equal to A transpose. What is A transpose? So generally A is denoted as Aij. So it's n by n matrix, n rows and n columns. Okay. So if first row elements are same as first column elements, second row elements, for example, for 2 by 2 or 3 by 3 matrix, 1, 2, 3. The first row is same and first column also must be same. 6 minus 1. This is first second column, so it must be minus 1. It may be any element. So this is symmetric matrix. So first row equal to first column, second row equal to second column, third row is same as third column. So this is symmetric matrix. If it is not same, rows first row is not any rows and any columns are not same. Means respective columns are not same. Means it is not symmetric matrix. Okay. So square matrix we are interested in studying square matrix. Okay. In that we classify two types of matrices. One is symmetric, another one is non-symmetric matrix. Okay. We classify that in that square matrix skew symmetric, Hermitian matrix, and many types of matrices we classify from the square matrix, diagonal matrix, scalar matrix, identity matrix. Okay. Okay. So in that what is that? This is a non symmetric matrix. We will call it as we important matrix, row matrix. The matrix having only one row is called row matrix. Matrix having only one column is called the column matrix. Column matrix or column vector, row matrix or row vectors. It's very important. So from that definition, from that row matrix or column matrix only we are getting the eigenvectors. Okay. So if we move on to the eigenvalues definition. Do you have any doubts?
No, sir.
definition, A be the n by n matrix. That means n rows and n columns. And a scalar is a real number or complex number. That number is called an eigenvalue of a matrix A if there exists non-zero vector, very important, non-zero vector x in R power n. So what in matrices, vector is nothing but row matrix or column matrix. Okay. So here it is a column matrix. Okay. So that vector. Okay. So here R power n means it's a column vector x1, x2, etc. xn. This belongs to R power n. Okay. So R1, R square. So you know R1, what is R1 is nothing but real number. R square is that is x1 comma x2. The elements will be like this. So like that if you take transpose for the row matrix, that is a row matrix, you will get a column matrix like that. So it belongs to this R power n. That's all. So in R power n such that satisfies this equation. So together eigenvalue and eigenvector definition exists. So for the matrix A. So if it satisfies this eigenvector x, this non-zero vector x, and the scalar lambda, then we call it as lambda is an eigenvalue of the matrix A, and x is the eigenvector of the matrix A. So the vector x is called eigenvector corresponding to the lambda, very important. So for this lambda, this is the corresponding eigenvector. Let A be an n by n matrix with the eigenvalue lambda or corresponding to the eigenvector. Thus Ax equal to lambda x. What's the definition? Suppose if you suppose if you have n by n matrix with eigenvalue lambda and corresponding to eigenvector, we will have this equation. That's Ax equal to lambda x. That is from definition of the eigenvalue and eigenvector. Okay, this equation may be written as like this because see, this is A is n by n matrix, n rows and n columns. X is n rows, one column. Okay, that is equal to lambda is scalar, x is n by 1. N cancel, you will get, if you multiply n cancel, you will get n by 1 matrix, that is right hand side. So this, suppose if I take to the left side, I will get this equation. So how I will get Ax minus lambda x equal to 0. From that, this is a matrix equation. So from that, I take x because matrix multiplication is not commutative. Okay, it's not commutative. In general, it is not commutative. AB is not equal to B. Okay. So x, if you take right hand side outside, what will happen? A minus. So it is only scalar. It is not a matrix. So for that, I take. So this I is identity matrix of order, that order of the matrix. What is the order of the matrix A? That is n. Must be n by n. That is the order of n. So So we get this matrix equation. This is a null matrix, which is also order n. No problem. So simply that null matrix is written as 0. No problem. Okay. So by writing that I is okay, I okay like that null matrix we write 0 only. Get this equation. By so to find this eigenvector we use this equation. To find eigenvector we use this equation. For lambda we will see that. So if you solve this matrix equation, we will find that is its eigenvalue lambda given. Okay. So by from the given lambda we can find eigenvector. You understand any doubts of this?
Sir, how did we write lambda as I lambda, sir?
Lambda as I lambda. Well, see, it is suppose I am taking matrix 1, 2, 0, 3. Some scalar lambda. This is A matrix. Sir, I lambda. Okay, this is A. I is 1, 0, 0, 1. Suppose lambda equal to 2. So 2I equal to I2. Both are same. See, if you multiply 2I, what will happen? 2I equal to. So we have to multiply every element by 2. So get 2, 0, 0, 2. Similarly, I2 also same. So this is I 1, 0, 0, 1 into 2. So scalar we can take because it satisfies linearity property. Matrix will satisfy linearity. What is linearity property? F of ax plus by equal to. So it will take that function will push that constant outside. That is f of x plus b f of x. So it will satisfy the matrix, it will satisfy the linearity property, so that no problem. That lambda will, so lambda I lambda equal to lambda I, both are same. Do you understand?
Yes, sir.
Solving the equation A minus determinant of that expression. How I am getting this A minus lambda I equal to 0. See, um, Ax equal to lambda x. This is the definition for both. What is that? Eigenvalue as well as eigenvector. So definitely must be non-zero eigenvector. It's a non-zero vector. Non-zero vector is said to be eigenvector of A if it satisfies this equation. Okay. So, so from that I am getting this Ax minus lambda x equal to 0. Also I am getting A minus lambda I into x equal to 0. Okay. So product of two numbers 0 means any one of them is 0. This is not 0. X is not 0. So definitely uh, this must be 0. Oh, okay. Matrix, this must be 0. So determinant also must be 0. So by solving the equation, this okay, for lambda leads to all eigenvalues of A. Usually we study only 2 by 2 matrix, only 2 by 2 matrix, and 3 by 3 matrix, because it is difficult to solve, difficult to find the eigenvalues of A for fourth order, fifth order matrices. Uh, so for 2 by 2 matrix, so this is a general representation. Okay, so we have the formula. We can use this general formula, or lambda square minus s1 lambda square plus s2 equal to 0. What is s1? So you want to find the eigenvalues of A by solving this equation or this equation for 2 by 2 matrix. So what is S1 is sum of the main diagonal elements of A. So this is main diagonal element, this is subdiagonal elements. So main elements are simply, we call it as just diagonal. Okay. So A11, A22. And S2 is determinant of E. Similarly for 3 by 3 matrix, lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is sum of the main diagonal elements, and s3 is sum of the minus of main diagonal elements, and s3 is s2 is sum of the minus of main diagonal elements, and s3 is determinant of A. So if we substitute that, we will get cubic equation in lambda, and by solving that, we will find the roots, that root we call it as eigenvalue of the given matrix. So on expanding determinant, we get the on expanding the determinant, we get the determinant. We get the polynomial in lambda. This polynomial, we call it as characteristic polynomial of A. The equation, we call it as characteristic equation of A. So we get this matrix. This is not matrix equation. If you take determinant, it will become algebraic equation. Okay. Example: find the eigenvalues and eigenvectors of the matrix. Matrix that is -4, -6, and 3, 5. So if you find the characteristic equation, we use the formula above formula above. What is that? Lambda cube, sorry, lambda square minus s1 lambda plus s2 equal to 0. So s1 is sum of the main diagonal elements. Minus lambda, sorry, -4 plus 5 is 1. So that is lambda square. S1 is minus plus 5. That is 1. So that is 1 is just lambda. And S2 is determinant of A, product of main diagonal elements minus subdiagonal elements, -20 plus 80. That is -2. -2. So the product must be -2. So what are the factors? 2 into 1, only 2. factors only for S2. So that is the large one must be negative. So that lambda minus 2. We can use quadratic formula also. Because it's complicated. So what is the roots are lambda 2, lambda equal to 2 and minus 1. You can use the quadratic that is lambda equal to minus e plus or minus square root of e square minus 4ac by 2a. You can use this also, no problem. So let us, that means we use general one. A matrix, just we find this expression. We find this expression. After that, we will take determinant. So A, we have to subtract that lambda into I from the main elements of A. So minus 4 minus lambda, 5 minus lambda. Only change. So remaining elements 3 minus 6 same. So if you expand, that is by taking determinant, you will get some of the, that is product of main elements minus subdiagonal elements. You will get this. So solve the characteristic equation of A. You will get by solving this, you will get the eigenvalues are 2 comma minus 1. The corresponding eigenvectors are found by using these values of lambda in this. There are many eigenvectors corresponding to each eigenvalue. That means what? Eigenvectors are not unique. So you understand up to this? Any doubts in this? If you have, you can ask me. So now we are going to find. Hello, can you hear me?
Yes, sir.
Okay. For lambda equal to 2, we find corresponding eigenvector. We solve the equation a minus 2i2 into x equal to 0. The matrix A minus 2i2 is obtained by subtracting that we know. This leads to system of equations. So what are the system of equations? What is the system of equations? Collection of two or more equations, we call it as system of equations. So from the matrix equation, we are getting this system of equations. So how we are getting? So what is A matrix? A matrix is minus 4, minus 6, 3, 5. A matrix is minus 4, minus 6, 3, 5. Okay. So I have to subtract the main, that 2i from the main elements of E. So that is 8 minus A minus 2i. I'm getting minus 4 minus 2. So remaining that element C and 3 and 5 minus 2. So if I A minus 2 I into x. So this is minus 6, 3, 3 into the eigenvector, that is non-zero vector of order. If it is n by n, it is n by 1 will come. If it is, as it is a 2 by 2 matrix, it is 2 by 1 matrix. So from this matrix equation, we get this algebraic equation. So multiplying corresponding elements go into column. So minus 6x1 minus 6x2 equal to 0. So, equal to, we are equating this matrix equation equal to 0. From that we are getting this. Similarly, 3 corresponding row 2 into C1. So 3x1 plus 3x2 equal to 0. So second equation also we got. See, both the rows are same. How it is same? If you divide R1 by, it is possible in the matrix elementary row or column transformation. If you apply them, it is equivalent matrix, you will get it. Okay, both are same matrix, you will get it. So if you apply the R1 is written as minus 1 by 2 into R1. So you'll get 3 will come. If you divide by minus 2, 1, what will come? Minus 1 is cancelled. 6 by 2, 3. 6 by 2, 3. So R1 and R2 will be same. So this matrix equation is equivalent to only one equation. So that is, if you divide this by, this is same, both are same. Okay. If you divide by 3, you will get x1 plus x2 equal to 0. So from that it is giving x1 equal to minus x2. See, one equation, two unknowns, you have to assume. You have to assume. So for simple eigenvector, I will take x1 by 1, x2 by minus 1, 1 minus 1. So first, this is the simplest one. So we have one parameter, that is r. So I am putting x2 equal to r. Therefore, minus r, where r is a scalar. Thus, the eigenvector of A corresponding to lambda equal r non-zero vectors of the form. This is the form. Okay. That is say this is the eigenvector x1, x2. What is doing? That is x2 equal to r. X2 equal to I have taken r. So that this is written as like this, and r into, okay, minus 1, 1. Because x1 equal to minus x2. If I take this x2 here, it becomes what? Minus x2. That is x1. So we have seen that it giving that x1 equal to minus x2. But in problem we will do that x1 by 1, x2 by minus 1. So corresponding x1 element's value is 1 and x2 value is minus 1. Like that. So we will get eigenvector like that for 2 by 2 matrix. If it is having same only one equation. So for x is r, so that eigenvector is this one. So next we are going to find eigenvector for lambda equal to 1. Do you have any doubts up to this? If you have doubts, you can ask. Now for lambda equal to minus 1, we are going to find eigenvector. We solve the equation a minus lambda I into x equal to 0, where lambda is minus 1, therefore plus 1. I is I2 because of A matrix is I2. The matrix A plus I2 is obtained by adding 1 to diagonal elements of A. So we get the system of equations minus 3x1 minus 6x2. So how we are getting that A matrix. What is A matrix? Minus 4 minus 6 3 5. Minus 4 A equal to minus 4 minus 6 3 5. So you know that A minus lambda, that is you have to add 1 to the diagonal elements. So that A plus lambda is 1, so that A plus I equal to minus 4 plus 1 is minus 3, remaining same, and 3 same, and 5 plus 1 is 6. So both are same. If you would multiply by minus 1, you will get 3 6. So it is also equivalent to one equation. The matrix equation is equivalent to one equation. So this, if you divide by this by 3, you will get x1 plus x 2x2 equal to 0. So from that, x1 equal to minus 2x1. If you have to assume, one value, that x2 equal to r, you can take. Okay. So from that, x1 equal to minus 2r and x2 equal to r. So another parameter also you can take, no problem. Yes, he has taken. Okay, same similar one. So now we go to the example to find the eigenvalues and eigenvectors. But what matrix is this one? Symmetric or non-symmetric? Symmetric matrix. R1 is same as C1. R2 is same as C2. And R3 is same as C3. So we have to find the eigenvalues and eigenvectors of the C3 matrix. So matrix is obtained by this matrix. It's a matrix, single matrix, because you calculate this, you will get single matrix. Okay, the matrix is obtained by subtracting lambda from diagonal elements of A. Why? So this lambda is nothing but only the diagonal elements are lambda, other elements are 0. So subtracting lambda from the diagonal elements of A. So 5 minus lambda, 5 minus lambda, 2 minus lambda. Okay. So it is very difficult to find that. So that find that is lambda q minus s1 lambda square plus s2 lambda minus s3 equal to 0. So s1 easily we can find. S1 is nothing but 10, 12. Okay, s3 determinant we have to find. Okay, and s2 is some of the minors of main diagonals. Okay, so what do you use? See, the characteristic polynomial of A is A minus lambda I. So A minus lambda I, using the row and column operation to simplify the determinants. So what we do, because it is very large values, it is very difficult to calculate. Okay, not very much difficult, somewhat it is difficult. So that what we do, we make, see, we want to find determinant value. We want to expand R1. We can expand along R1 or R2 or any rows, along any rows or any columns, no problem. But we are interested in expanding along R1, so that I want to make this element and this element are 0, so that easily we can find only one term will come. So that I want to make this element 0. So what I do, first I see that these are same. A13 and A23 are same. So that I apply the transformation. What transformation I apply? R1 is R1 minus R2. I apply. Then only 2 minus 2 0. So 5 minus 4, it is 1. 5 minus 4, 1 minus lambda. 5 minus lambda minus 4, that is 5 minus 1, it is 4. 1 minus lambda is coming. And 4 minus 5, it is minus 1. Minus 1 minus plus lambda. So 2 minus 2, 0, no problem. Next, I have made this element 0. If I take again row element transformation, you will get this term not 0. So don't take row elementary transformation. So that I take column elementary transformation. So we cannot go for this because it is 0 only. You have to go for this one. So if you add this minus 1 plus 1, it is 0. Lambda minus lambda, very simple. So that C2 is C2 plus C. So that this term becomes 0. Okay. So that 5 minus lambda plus 4. 5 plus 4, it is 9. So it is 9 minus lambda. 2 plus 2, it is 4. That's all. So we simplified it. Now we expand along R1. So if we expand along R1, what will happen? 1 minus lambda product of this and minus subtract 9 minus lambda, 2 minus lambda, 4 into 2, 8. So if you expand this, so 1 minus lambda is as it is. If we expand this 9 into 2, that is 18. 18 minus 8, that is 10. So next, 9 minus 9 lambda minus 2 lambda, it is minus 11 lambda, and minus lambda into minus lambda, it is plus lambda square. So from that, so I want to factorize this. To factorize, so product must be 10. Sum must be roots of sum must be. So what are the factors of 1 into 10? 5 into 2 also coming. Okay. So only these factors. Okay. So this is not possible because sum or difference is not 11. So both are minus. So that if you add to it will get minus 11. If you product, you will get plus 10. So lambda minus 10, lambda minus 1. So if you adjust this, minus of lambda minus 1 will get it. From that, lambda minus 1 whole square, lambda minus 10 into minus. Do you understand any doubts? If you have any doubts, you can ask me. Now, we now solve the characterization of A. So by solving that, we will get that is this is a characterization. This is a characteristic this is a characterization. We make this expression. This is the expression. If you make it is equal to 0, we will get characterization of A. So by solving this, from that we'll get lambda equal to 10 and lambda equal to, it is 1 comma 1. That eigenvalue. The corresponding eigenvectors are found by, simply we can write only one only because it's the same. The corresponding eigenvectors are found by using three values of lambda in the equation. So lambda equal to 10 we get, okay. So that is 10. We have to subtract from the A matrix. That is 5 minus 10 is minus 5. 5 minus 10 is minus 5. This is okay, what is A matrix? 2. 2 minus 10 is minus 8. So from that, all rows are different. How will you find the? It is very simple. Using leaving column method. Leaving column method, x1 by equal to minus x2 by and equal to x3 by shortcut method. So I take first and second rows. If I leave this column for x1, so corresponding product of main diagonal minus subdiagonal 8 minus 10. That is what is 8 minus 10? That is 80. And x2, we leave this column minus 5 minus 10 minus 8. Minus 10 minus 8. Next, leave this column for x3 plus 25 minus 60. 25 minus 60. So what I am getting, x1 by 18, x2 by minus 2 minus plus that is minus 18, numerator minus denominator minus, it is plus 18, and x3 by 9. 25 minus 6 is 9. So if you multiply by 9, you'll get x1 2, x2 by 2, x3 by 1. This is 2 to 1. This is, the simplest eigenvector is unique. Okay, you will get many eigenvector, but simplest eigenvector is multiples. Okay. So how we are getting x1, x1, 2r. So from that we are getting x1 equal to 2r, x2 equal to 2r, x3 equal to r. Okay, that is we got no x1 by 2, x2 by 2, x3 by 1 equal to some r. From that x1 equal to 2r, x2 equal to 2r, x3 equal to r. So r is a scalar. Thus the eigenspace of is one dimensional because it depends on only one parameter. The n is a one dimensional space of vectors of the form. Okay, so 2 to 1. And lambda equal to 2, that is lambda 2 equal to 1, we get the matrix equation a minus lambda, so like 442, 442. Okay, so two equations are same. So because three unknowns, I think the third also same, I think. Okay, it is equivalent to single equation. So 442. A matrix. A matrix. 2 2. Yeah, the matrix is 2 2 2. Four, four, again 4, 4. So it is 2, 2, 2 minus 2 is 1. So all three rows are same. If R1, R2 are same, if you divide by 2, you will get. If you multiply by 2, R3, you will get. Okay, so it is equivalent to 2x1 plus 2x2 plus x3 equal to 0. So three unknowns, only one equation. This matrix equation is equal to only one equation. So what you have to do? You have to assume. So assume x3 equal to some multiples of. So I take 2r or 2s. Okay, any. So suppose I am taking 2r. Okay, so we have to assume for two values. So I assume for a x3 and x2. X2 equal to simply yes, because it is already. So now I will get x1 from the equation 2x1 equal 2x1 is um, 2 into s, x2 is yes, we have assumed, and x3 is 2r equal to 0. 2x1 equal to minus 2s minus 2r. So x1 equal to minus s minus r. So already we used r, so that okay, we can use another parameter also, no problem. T. We have used, I think T only here. Okay. So same thing. So another method, shortcut method is very easy. So 2x1 plus 2x2 plus x3 equal to 0. If it is like that, we have to assume one value is 0. I assume x3 equal to 0. So that what I will get, 2x1 plus 2x2 equal to 0. From that x1 plus x2 equal to 0. X1 plus x2 equal to 0. From that x1 equal to minus x2. From that x1 by 1, x2 by minus 1. Definitely it will be orthogonal to this one. So symmetric matrix eigenvector must be orthogonal. What is by orthogonal? So x1 transpose x2 must be equal to 0. So this vectors, what is a dot product is 0. A dot B vector is 0 means both are perpendicular. Vectors are perpendicular. Okay. So that these are orthogonal to each other. That is, you have to take transpose and only we can multiply. This is the definition for orthogonal. So it must be orthogonal. Definitely this will be orthogonal to this one. So that is simplest eigenvector 1 minus 1 0. So simplest eigenvector 2 2 1. Okay. If you multiply corresponding elements 2 minus 2. Okay. 2 minus 2 plus 0 and 1 0. That is 0 will come. Okay, even if you assume 2x1 equal to 0, definitely it will be orthogonal. But x3 you have to take is LMN such that x3 transpose x1 equal to 0, x3 transpose x2 equal to 0. By solving this, you will get x3 element. Leaving column method we will apply. So it is a two-dimensional because it depends on S and T. Separating the parameters S and T, we can write. Okay. You will write S. This is a eigenvector corresponding to lambda 2 equal to, you write like this. The eigenspace of lambda 1 is a two-dimensional space subspace of R. Base is two bases. So this is two bases. Get problem. Consider the following matrix. So find the absolute value of product of eigenvalues. So it is very difficult to find the eigenvalues of 4 by 4 matrix in our usual method. But if you use the properties of eigenvalues, it is very easy. So what are the properties? Product of eigenvalues equal to determinant of A, and sum of the eigenvalues is sum of the main diagonal elements. This is for CAC and IT gate question 2019. Now this is the properties of eigenvalues. I can use this. Listen, it is very difficult to find characterization, and I want to find absolute value of this one. That is, this is what we need. This is what we need. Product of eigenvalues, absolute value. So what I am going to do means, I am going to get equivalent matrix, that is triangular matrix. You know that triangular matrix eigenvalues are just diagonal elements. Okay, our determinant of triangular matrix is nothing but product of the diagonal elements. So I am going to apply elementary transformation. I want to make this is a pivot element. This is a pivot element, key element. Okay, I want to make this these elements are 0 first. Okay, below the key element. So R1. Okay, R2 is written as R2 minus R1. R3 is written as R3 minus R1. R4 is R4 minus R1. So if you do that, 1 minus 1 0. So all are 0. 3 minus 2. 9 minus 4 is 5. 27 minus 8 is 19. And 4 minus 2 it is 2. 16 minus 4 it is 12. 64 minus 8 it is 56. And 5 minus 2 is 3. And 25 minus 4 is 4. 125 minus 8 is 170. So again, I want to make these elements are 0. So that R3 is minus 2 R1, minus 2 R3. R4 is minus 3 R. So I am taking. So that we can apply, or otherwise, if you as it is a multiple of 2, this one, as it is a multiple of 2, as it's a multiple of 3, you can divide by 2. That is, R2 is 1 by 2, or 0 by 2 is 0, and R3 is 1 by 3 R3. Okay, now this is 1, 7 and 39. So now we can easily apply. That is, so otherwise you can take commonly from R2, that is from R3 to from R3 is 3 if you take outside. Okay. Now it is 2 into 3, it is 6. Next, I want to make this element 0, this element 0. So make R3 is R3 minus R2, R4 minus R2. So that we get this thing is 0. 6 minus 5 it is 1, and 28 minus 19 it is 9, and 7 minus 5 it is 2, and 39 minus 19 it is 20. So after that, I want to make this element is 0. So that what I will take, R4 is R4 minus R2. So that it is 2 into R. So 2 minus 2 0, 8, 20 minus 8, 9 is 20 minus 18 it is 2. So product of eigenvalues, that is our determined values 2 into 6 12. So the absolute value of that lambda 1 lambda 2 lambda 3 is 12. Problem. The let is x be the square matrix. Consider the following two statements on x. That is x is the square matrix. First statement, x is invertible. What is mean invertible? Invertible means it is not singular. It is invertible means x is not singular. X is not singular. X is not singular, and determinant of x is not zero. Second statement is which of the following is true? First one implies two, or two doesn't imply one. Two implies two. Sorry, two implies it must be one. One doesn't imply two. One doesn't imply two. Two doesn't imply one. One and two are equivalent statements. Answer is B, because these are our equivalent statements. Determinant zero means definitely it is non-similar. Non-similar means definitely we have the theorem. So we know that matrix A is invertible if one only is A inverse exists. So that by result we write B is correct. Or otherwise we are using that suppose matrix A is invertible, A inverse exists. Okay. Now determinant of A into A inverse. So what is the is I is not equal to 0. So determinant of AB is determinant of A into determinant of B. From that, you know this A into A inverse is I. It is not 0. So that A inverse exists. A inverse is not 0. A inverse is what to say, determinant of x is not 0. It is 0. If it is 0, definitely cannot be equal to 0. Okay, so that it is non-zero. That means A inverse exists means determinant of A is not equal. Third one, two eigenvalues of 3 by 3 real matrix P are 2 plus square root of minus 1. It's a great problem. Two eigenvalues are given. I want to find determinant of P. I know that for 3 by 3 matrix P, lambda 1, lambda 2, lambda 3 is determinant of P. No problem. But only two eigenvalues given. How to find another one? Any idea? This is what is square root of minus 1? This side. Okay. Okay. So from that we have to find another, that is another eigenvalue. Using that I want to find product. That product is our required determinant of P. Okay. So what is the why? How we are finding? Complex root always occur in pair. So another eigenvalue is 2 minus I. So 2 plus I, 2 minus I, and 3 equal to determinant of A plus IB, A minus IB, A square plus B square. P is 1. A plus IB, A minus IB, it is A square plus B square into 3. That is determinant of P. So 4 plus 1, it is 5. 5 into 3, it is 15. So determinant value is 15. determinant of P is 3. And suppose that eigenvalues of eigenvalues of a matrix A are 1, 2, 4. Then the determinant of A inverse whole transpose is we want to find. So given data are lambda 1 equal to 1, lambda 2 equal to 2, lambda 3 equal to 4. We know the property A and A transpose have same eigenvalues. Can you hear me? Hello?
Yes, sir.
Yes,
Okay,
sir.
okay, okay. A and A transpose have same eigenvalues. And if lambda is an eigenvalue of A, then 1 by lambda is an eigenvalue of A. So by using these two results, we can find the determinant of required matrix. Required determinant of a matrix. Okay. See, I want to find A inverse eigenvalues. So eigenvalues of A is 1. A inverse eigenvalues 1 by 1. Right. So A inverse and A transpose are having same eigenvalues. So that's no problem. Because A and A transpose have same eigenvalues. So for A inverse and A inverse transpose also have same eigenvalues. So determinant product of product of the eigenvalues. Determinant is product, that is 1 by 8. So n 1 by 8. The lambda is 1 by lambda is eigenvalue of A inverse. So given that 1, 2 are the eigenvalues of A, this implies 1 by 2, 1 and 1 by 4 eigenvalues of A inverse. Also 1 by 1. Okay, so that by property. So this is also eigenvalues of this one. So product is 1 by 8 is the answer. The larger of two eigenvalues of the matrix. It's a great question. So it is very easy. If you find the characteristic equation, if you solve that, you will get two eigenvalues out of the two eigenvalues, which is large. That one is our required value. So lambda square minus s1 lambda plus s2 equal to 0. So lambda square my s1 is 4 plus 1, that is 5. Some of the main elements. Product of main that is a determinant of a 4 minus 10, that is 4 minus 10 is minus 6. So minus 6 factors, 2 3 coming, 1 6 coming. That's all I think. Okay, if I do this minus 2 minus 3 minus 5 is coming, some coming, but product will not come. So do that so that it is not possible. So if I do this minus 6 plus 1, so it is minus 5 as well as minus 6 product. So out of this, lambda minus 6, lambda minus plus 1 equal to 0. So that is lambda equal to 6 comma minus 1. Out of this, 6 is the largest one. So our required eigenvalue is largest eigenvalue is 6. So sixth one, last one. Consider the following 2 by 2 matrix where two elements are unknown and are marked by A and B. The eigenvalues of this matrix are -1 and 7. This is also all problems are gate question only, not some problems. These are problems 1 to 6 all are gate problems only. So the eigenvalues of this matrix are -1, whether it is either in CAC or CAC IT or EC mechanical, like that. All problems are from gate problems. What are the eigenvalues of? What are the values of? It's not. What are the values of A and B? You want to find A and B values. So given data is, what is the given data? Lambda 1 equal to -1, lambda 2 equal to 7. Okay, it is the given data. So we can use uh, lambda 1 plus lambda 2 equal sum of the main diagonal elements 1 plus A. So that is sum of the main diagonal elements. Lambda 1, lambda 2, lambda 3. So 3 is not available. Only lambda 1. Lambda 2 is product of A minus 4. So product is -7. Uh, lambda 1 plus lambda 2 is 6. 1 plus A. A equal to 6 minus 1, 5. So A equal to 5 option is correct. This option is correct. No need to find another value. Definitely 3 will come, no problem. Okay, we can stop up to that because so okay, this is -7, no, -7 equal to A minus 4B. So -7, A value is 5, minus 4B. If I take so what will happen? 4B. If you take left side is plus 4B, -1 goes to there is plus 7. 12B equal to 12 by 4, that is 3. So option 4 is correct. Find A value, other A equal to 5 is not available in any options. You can stop up to that. Your right fourth option is correct. If you have any doubts, you can ask.